what is a catalyst? A catalyst is simply a substance that you can add to a reaction and it speeds up a reaction. Okay, so now this happens in 90% of the cases. However, there are some cases where a catalyst is added as a negative catalyst, which means it slows down the reaction. Okay, um, we will focus our discussion on catalysts that speed up a reaction, which is the most common scenario. So the question is, how do these catalysts speed up reactions? So imagine an energy profile diagram out here. You have energy going upwards, and then you have the reaction on the horizontal axis going this way from reactant to product. Now, under normal cases, let's say you have your reactants out here. They go up, and let's say the energy barrier is really high. So you need a huge activation energy to surmount that barrier to be able to get to your products. Now, when the energy barrier is really high, you need a high activation energy. The reaction is going to be a very slow reaction. Okay, so what we can do is we can add a catalyst. Okay, and when you add a catalyst to the reaction, then it actually changes the reaction pathway. So instead of it going up there, a catalyst would say, hey, you know what? I'm going to take you along this path to get to the same products. Okay, so the reactants plus catalyst goes up this path and goes down there. So now you see, by comparison, your activation energy is much smaller as compared to this gigantic amount of activation energy needed for going up that hill. Okay, so that's what a catalyst does. It changes the reaction pathway. Okay, and that's how it speeds up the reaction. Now, a couple of things about catalysts. A catalyst, once put into a reaction, is always going to get regenerated. Concentrations don't matter when it comes to catalysts. So as long as you have a little bit of the catalyst, the reaction is going to take place. Okay, and so an example of, let's take for example, the production of ammonia from nitrogen and hydrogen. This is a very difficult reaction, by the way. Okay, so you have nitrogen plus hydrogen and you're trying to make ammonia. This is called the Haber process. Okay, the Haber process. It's a very famous process to make ammonia. Okay, so you have nitrogen, hydrogen to make ammonia. Let's go ahead and balance this. So you have 2 out here, 3 out there, and 2 out there. Okay, now it turns out this reaction is very hard because nitrogen has a triple bond. Okay, and it's very hard to break that triple bond, and so you need a catalyst. So the catalyst that is used in the process is iron. Okay, iron is used, and as a result of that, the reaction becomes much easier. Okay, so now iron out here is a solid catalyst. Okay, everything else is in the gas phase. So therefore, the phase of the catalyst and the phase of the gases are actually different. So iron in this case would be an example of a heterogeneous catalyst. Okay, so a heterogeneous catalyst is simply a catalyst that is in a different phase from the reactants. Conversely, another type of catalyst called a homogeneous catalyst. A homogeneous catalyst is a catalyst that is in the same phase as the catalyst. So an example of a homogeneous catalyst are chlorofluorocarbons. Chlorofluorocarbons. These are also known as CFCs. So these are produced from refrigerants, okay, and basically what they do is they go up into the ozone layer and they deplete the ozone layer. So these are gases. Ozone is also a gas. They deplete the ozone layer because they make it much easier for the ozone to break down, okay, and as a result of that depletion, the sun's harmful UV rays come through, and then that causes a lot of skin damage. Okay, there are other issues that happen from that, but long story short, chlorofluorocarbons act as a homogeneous catalyst. There are many other homogeneous catalysts, but essentially what you need to take away from this is homogeneous catalysts are catalysts that are in the same phase as the reactants, and heterogeneous catalysts are catalysts that are in different phases, is in a different phase from the reactants.